Welcome guys. So in this video, I want to talk about the area of triangle. Okay, so this is a very small topic. Everybody in the junior high school, elementary high school, or the senior high school. Okay, so there are four computational four formula of the triangle area. One let's say triangle is ABC. So the first thing is that if you only know A, B, and theta, so you know A, B, and theta. This is a very famous formula called AB sine half AB sine theta. Okay, so let's say if you know ABC, this is the famous Heron's formula. So if you don't know, let's say S is the half of parameter, then the area will be S times S minus A, S minus B, S minus C, and take a square root. Okay, and if you don't know about the formula, you can go to my channel and type the Heron's formula, and there's a detailed proof. Okay, and actually, you can easily prove that if you start from half AB sine theta, you can prove Heron's formula. Okay, and the 3 is the obvious one, right? So if you have a and you have a height h, then this is a half ah. Okay, and it's easy to see that a half h will imply a half AB sine theta. So yeah, so we know we have 3 proof 1 proof 2. Okay, but and you can easily to prove that 2 is actually implies 3. Okay, so I mean I don't have to prove it. Okay, but in this video I want to talk about the final one. Is that if you put all your you have 3 points on a plane, and there's a formula say that the area is a half x1 y1 1 x2 y2 1 x3 y3 1. So this is a determinant, but you take the absolute value. Okay, so this is the first formula of area of triangle. So in this video we want to prove it. Okay, so I should say I want to prove it, probably not you. Okay, so let's see the proof. Okay, so what we will use is the generalization of this guy, right? So this can be extended to, this is the same as a half a cross b, right, with the determinant. So it's easy to prove this. Okay, so let's see. Let's say we have this, right? And let's say this is A, right? This is B. So our A will be x1 minus x2, y2 y1 minus y2, y1 minus y2, and our B will be x3 minus x2, y3 minus y2. Okay, then that we calculate A cross B, which is trivially. So that's brute force calculated. How do we calculate it, right? So right. So remember, let's see. Okay, so remember that if you have 2 vectors, one is a1 a2 and b1 b2, then what is what is the cross, right? Cross. So this is one vector on plane, another vector on plane. So the answer will be just a number. It's a1 b2 a2 b1, right? So the direction will be z hat. So if this is x, this is y. Okay, so if you just cross and take the absolute value, you just take the absolute value of this times this minus this times this. So we get x1 minus x2, y3 minus y2, minus y1 minus y2, x3 minus x2. Okay. So let's see what is this. So this is x1 y3 minus x1 y2 minus x2 y3 plus x2 y2 minus y1 x3 y1 x2 y2 x3 y1 x2. Okay, so if I'm not stupid, then these two terms are the same, so let's cancel it. Okay, and let's open the parentheses. Okay, and we combine. Okay, so now everything is clear. Then we combine it. Okay, so let's see. The first guy is what? This is x1 y3, right? So this is a cross b. Let's take a half. Okay, so this is the answer. Obviously, if I expanded this out, I get a is a half. So the first thing turns x1, right? y2 minus y3 minus y1 x2 minus x3 plus x2 y3 minus x3 y2, right? So this is the expansion of determinants. So we get x1 y2 minus x1 y3. So let's write it. Hopefully we can get it. So we get x1 y3 minus y2, and then let's say we get y1. So we get y1 x2 minus x3, and then we get the y2 x3 minus x2 y3. So you see these two terms are the same, but there's a negative sign here, right? But we get a determinant. Okay, so actually this term is the same as this term, right? Because there's a determinant, there's a absolute value here. So we get, you see, this is x2 y3, x2 y3, this guy. So this is exactly the same as this. Okay, so proof are done. Yeah. So the proof is just we just expand a cross b, take a half, and compare with the determinants, and everything will be trivial. Okay, so yeah, this is just summarized to prove this determinant formula for the triangle. Okay, so that's it. I will see you guys in the next videos.